Well, I'm Miguel Fontanilla. I'm currently the leader of the platform team at Sender, where I work with Felipe. I'll tell you a little bit more about the company later. I'm tightly related to AWS. I do not work for them, but I'm part of the community builder program. I'm also certified as a professional architect, and I got certified recently as a professional GenAI developer. So I guess you can trust what I say. I'm also part of the Platform Engineering Ambassador program. So I tried also to give back to the community the things we're learning by doing. You have there my connections, and I'll share the presentation in the WhatsApp group later because there are a lot of links you might find useful. So feel free to use them. So about Sender, pretty quick. Most likely you don't know about our company. Only Miguel, Felipe, and I probably know about it because we work there. But it's what we call a digital freight forwarder, which is basically a marketplace that connects companies that have trucks with companies that need to move loads across Europe, and you take a margin per operation. Simplified, I like to say we're like Uber, but with trucks. And I've been 6 years with the company, and during this time we have adopted the platform engineering paradigm. You might not be familiar with this paradigm, depending on if you're working in software solutions or not. But the idea is to have a central team that builds abstractions to empower developers and to ensure they are self-sufficient as much as they can. So in that line, let's say about a year ago, we decided to start investigating how to build agents, focusing them on platform engineering, like to try to increase developer self-sufficiency, obviously, in the things we can help them with, improve the code quality, and also with an aim to improve the incident management and find solutions earlier maybe, or detect the root causes. Some of the things are already shipped, some of the things we're still working on them, but I'm gonna talk also from the experience we have on these areas. So the agenda we're gonna follow today, and I promise I'm gonna try to make it quick. We're gonna start with a briefly review of what an agent architecture looks like. Then we're gonna talk about a couple of frameworks you may already know about. Then we're gonna go over these frameworks, analyzing threats and mitigations, and then conclusions and lessons learned. I really hope you like architecture diagrams because there are quite a lot of them. Again, feel free to stop me at any point. I'm gonna start with agent architecture. Before I start, who's already working with agents? Who's building agents here? One? Who knows or who thinks that know what the architecture of an agent looks like? No one? Wonder? Okay, then I'm gonna take a little bit more time. So I'm gonna start with the definition of AI agents from Google. The whole definition is not the important thing, but there are little keywords marked there, as you can see: autonomous, LLMs, goals, usage of tools, remembering context, working independently. These are gonna give us an idea of what an agent needs to do. And here there's another definition from IBM, same idea: having a goal, limited supervision, and decision making. So why am I telling you about these buzzwords? Because we're gonna use them to try to derive an agent architecture, how it has to look like. So we've discussed about LLMs. Clearly, those are the ones doing planning, reasoning within this architecture. Then we need more than just an LLM to reply. It needs to adapt, it needs to be proactive, it needs to reason. So that's why we have SDKs or agent frameworks. Then you need to define the goals. That's why we have prompts, instructions. Then the agents should have memory. They should learn, they should remember from previous interactions. They also use tools to communicate to the external world through protocols like MCP, for example. And they also need to collaborate with other agents and with people, with protocols like A2A or AGUI. The second one is a little bit more new. I'll talk about that later. So with these buzzwords, put it into context, we can derive a first very high level architecture of what an agent looks like, right? In the end, the agent would be everything. I mean, you have the user and app that is interacting with the whole agentic, let's say, system. And if you think about it, it's just an SDK being a bridge towards the LLM for the rest of things. An LLM is just a brain in a bottle, right? You have an SDK in between, an agentic framework that is gonna interact with the memory to store things that the agent might have learned, access tools, use retrieval augmented generation on vector databases, and follow a goal defined in a prompt. So this is the very basic architecture of an agent, high level. Obviously, we're going to go deeper, right? So this is pretty much what an agent looks like, a real modern agent you might be using. Don't worry if you cannot see every detail. I'm going to go over them. But it's just what we've seen expanded. So as we said, we're going to have people, agents, and maybe applications interacting with your agents. So you're going to have different protocols. You might have an application, it's an HTTPS. Then you're going to have users, normally through an interface. Here's where AGUI comes. You might have other agents using protocols like 828. And also you might have a shared memory between agents so they can coordinate. You're also going to have a model provider. We're assuming you don't have a huge data center to run your models and train them. Things like guardrails to control, inputs and outputs of the models you're using. Then, of course, we're going to have external services because we want our agent to interact with everything. Maybe MCP servers to interact with these thingies. And as we saw before, you're going to have memory and vector DB. And here I'm making a distinction between long-term memory, which are things that your agents are learning between sessions, insights that you want them to remember, and short-term memory that normally are kind of short-lived, and they might be, within the, let's say, life cycle of the application. And obviously, it's 2026. I'm assuming you are placing your agent within a container, isolated host, VM, whatever you want to call it. What's the Agentic SDK? This green line. Here's where we have all the functions and abstractions to interact with tools, to interact with MCP, to manage your session, to manage your memory, to interact with external databases or knowledge bases. All in all, to abstract the difficult part of building an agent. Any questions up to this point? We get the general architecture. Cool. So now I'm going to talk about frameworks for threat modeling in relation to this architecture. So I'm going to go pretty fast because you have all the links. OWASP GenAI, probably you know more about this one. They're known by the top 10 in a lot of different areas. But then we have CSA, Cloud Security Alliance, with a relatively newer framework we're going to talk about, which is MAESTRO. So when it comes to OWASP GenAI, there are two links you have here, which are the ones I've been using for this architecture we just discussed, which is top 10 for agentic applications and agentic AI threats mitigations. But you will see also other links I've left there. If you're interested in developing agents, that might be really useful. If you're building MCPs, using MCPs, how to handle data securely when using agent architectures. So OWASP GenAI, I assume most of us are knowledgeable about these guys. But let's talk about this other one. The image is not that easy to see, but we will see it better later. So MAESTRO is a framework which stands for Multi-Agent Ecosystem, Security, Threat, Risk, and Outcome. It's a new way of analyzing multi-agent and agentic systems in a layered way. The idea is to cover the whole agentic landscape from the lower level to the upper level. And you have links there for a couple of resources. The paper where they present this model, CLI tool in GitHub you can use to analyze your agentic system, and a review by Sneak on the Sneak blog, which we've used pretty much to define the analysis we are going to be doing in the next steps. So this is pretty much, I think, about the frameworks. I'm going to be quick on this. And let's go to the fun part. Actually putting these frameworks into play over the architecture we discussed before. So I'm going to expand a little bit more on MAESTRO, because as you can see here, there are a lot of layers, 7 layers, and just going to give you a glimpse of what each layer is considering here. So the first level, the foundational one, refers to the models themselves, the training data that has been used, the model weights. Second level, which is data operations, you're going to have RAG, you're going to have knowledge bases, memory, embedding vectors. Third level is the Agentic SDK, Agentic framework. Fourth level is the actual infrastructure where all of this runs. Networking, containers, hosts, you name it. Orchestration for containers as well. Level 5 is evaluation observability and normal observability. So not only auditing and logging from the point of view of the infrastructure, but also from the point of view of the agent behavior. Is the agent behaving as it should? Level 6, it's more about compliance, access control, and policies. Here is where IAM is going to go. Same for guardrails, compliance controls. And level 7 is the agentic ecosystem. This is more focused on registries, protocols, discovery between agents, and so on. You'll see it in perspective now over the architecture. So on the other side, these are some of the top 10 defined by the OWASP top 10 for GenAI applications, if I recall correctly. Obviously, I'm just focusing on a couple of them, the ones that are marked, because otherwise it wouldn't be a lightning talk. So, but anyway, the idea with this exercise we're going to do together is that you understand how these two match together and how Maestro allows you to catch the interlayer dependency when identifying vulnerabilities and also how to mitigate them. So, remember the architecture we discussed before? Let's now map it to Maestro layers. So, if you recall, the lower layer was about models, model training data, and so on. So, will be in this case delegated to our model provider. Then we're going to talk about data operations. So, we have our second layer here, which are vector databases as well as long-term memory or memory in general. Then we have the SDK. This one is simpler because if you recall, the SDK is surrounding all these libraries and abstractions to call everything else. Layer 4, obviously, it's container orchestration, host, actual networking. In this case, well, we are representing it like this layer that we are kind of locking the agent within. Level 5, monitoring or observability in general. So we're getting signals from the infrastructure, but you're also getting signal from guardrail providers, model providers, and so on, memory, because you need to see, as we said before, if the agent is behaving as it should, if it's been compromised, if it's following its goal. Then, security and compliance, access control. We have guardrails here in this case. We could also mention here IAM policies and everything depending on what kind of ecosystem you're using. And finally, the agent ecosystem. This is more of a registry, which, by the way, I forgot to mention before. Registries in this area are mostly used for publishing agents, publishing skills, publishing protocols, spinning protocols versions, so that agents can recognize each other. And yeah, layer 7 includes all types of communications with other applications, users, other agents, you name it. So I know it's a lot, but what Maestro is doing is segregating the different layers so that you can analyze them independently, but also detect dependencies between layers. Now let's do the exercise together. If you recall, we had like these from the top 10 vulnerabilities from OWASP. So let's try with this one, for example. So agent goal hijack. We're going to do the same for all of them. Threat, impact, and remediation. So an attacker could inject a prompt, a file, a malicious email that might compromise or alter the behavior of the agent. Then that might silently change how the agent is doing their plan. And finally, it can compromise the whole autonomy and decision-making process. The impact is clear. It's on level 3 because it's on the SDK. The agent decision-making is clearly compromised. Now, how do you remediate this? This is where Maestro is powerful. You remediate it in 3 different layers. You have to log your goals, system prompts, if possible, and also version them, which is a good practice. On the level 5, under observability for behavior, validate user and agent intent before there's an action with high impact. This is about humans in the loop. Level 6, treat all external natural language inputs as unreliable, which means use a guardrail for every input, every output that might end up in something like a goal hijack. you're gonna see different, you're gonna see some asterisks. This is for a little thing I'll explain in the end. So another example, you might have an agent which has legitimate access to tools with fine-grained control permissions. That is fine. But it might happen, for example, that chaining different tools, if basically if a rogue user makes your agent chain different tools that independently are not dangerous, they might result in, let's say, behaviors that are not anticipated. So you can have impact on different layers. Unauthorized API calls from the SDK. You might have infrastructure tool exploitation if your agent has access to the infrastructure through tools. And in the end, you might end up doing malicious use of external services. Same idea. You have an impact on 3 layers. Remediation. Level 5, require approval for destructive or high impact actions. Same idea. Human in the loop. Level 6, least privilege principle for all the tools. This goes to IAM, fine-grained permissions. Level 7, use rate limiting, schemas for tool calls, and egress controls. I think you kind of get the point, right? It's guiding you into how to address it into different layers. Let's see, one more maybe. Yeah, this one. This one is lower level, but same idea. You can poison memory. You might be able to introduce an insight into an agent that goes into a memory, and then that can modify in the future the way in which the agent is gonna make decisions. Same idea as before. Or if it's some shared memory between agents, the compromise might be even bigger. So the impact here, it also depends on how you use your memories. It might be that we are just consuming models, but I can tell you that there are model providers that use their memories to retrain and fine-tune their models. So if you have a compromised memory, you might be training a new model with already malicious inputs. You can also have poison embeddings in your rack or in your memory, and same idea as before. In level 3, in the SDK, you're gonna have contaminated decision history. I think you kind of see the propagation chain. And here you have best practices, same idea. Scan memory writes before storing them, which can also be level 6 with guardrails, with things like contextual grounding check. Segment memory by user, by tenant, by task. This is also pretty standard practice. Like use the user ID, the session ID to segment memory so that you have a controlled blast radius if there's something that is poisoned. And also, it's interesting to be able to expire low trust entries. So I can follow like that, but I think you get the idea. You're gonna have the slides. Same idea, insecure agent-to-agent communication. So it affects multiple layers, and the remediation is done in different layers. So what I want to show you with all of that and with this idea is like, let's go over the conclusions, and then if you want, we open like a question turn in case there's something. So after this analysis, going over these examples of the different vulnerabilities and how Maestro addresses them, I think it's clear that when you have a multi-agent system or agentic systems, production-grade agentic system, attack surface is wide and complex because you might have multiple layers, multiple agents, multiple steps in decision making, and emergent behaviors you might not anticipate even when designing the system, like tool chaining, like goals changing or being compromised. Traditional threat modeling frameworks fell short. I forgot to mention like Lidun, Pasta, all of them. If you check the article that is shared on the slide about Maestro, they kind of critique top threat modeling frameworks, and they mention why each one is falling short for this kind of ecosystem. And this is why Maestro comes in handy. Again, it's layered. It goes from the lower level of model to the whole ecosystem in layer 7. Also analyzes a cross-layer dependency. It's not isolated to one layer. You saw how one vulnerability in level 3 can, get to level 7, and it's prepared to be expandable. It's prepared for the future. Let's say it's been designed so that it can be expandable for future use cases. And one more thing. If you remember, there were some entries with asterisks, and it is because in our experience, when you have to protect the whole architecture that we shared before, you have a lot of things to protect, right? You have to have guardrails. You have to ensure the IAM privileges are the right ones. So there's a architectural choice we did in the past, which is a proxy or an LLM proxy, LLM gateway, whatever you want to call it, that offers several benefits. And the ones that are marked here are the most interesting from the point of view of remediations that we talked before. One of the things a proxy is going to give you is observability. All the LLM calls, all the tool calls that are going to happen through the proxy, you're going to be able to track them, see what happens, see how they were executed. Then, of course, you have things like model routers, token consumption. This is more from the FinOps side. We're not focusing on that. You can use it as an MCP gateway to have just a single entry point to multiplex to several MCP servers. Access control granularity. You can control what identity can access what tool, what identity can access what model. Rate limiting, also used for level 7 protection. Caching budgets, again, that's FinOps. And also you can use guardrails at a global level because it's your single entry point for calling inference. So this is the way we do it. Felipe can tell you. We have agents, but we also have tooling, which are calling different models from different providers, different clouds. So we have introduced a proxy in between that, as we said, it gives you observability because you can get the calls, you can get the traces. It allows you to implement guardrails globally. It has other benefits like caching, but the most important one probably is fine-grained permissions because you can control, as I said, what is being accessed by whom. So the whole idea with this, what I'm telling you about this, if you recall our architecture, how it looks like, it's, it could be a mess, to focus on this when you're going to do the analysis. But if you introduce something like we do, suddenly all your MCPs, all your access to models, all your guardrails, observability, even the registry, because some proxies we are using a very particular one, which is Light LLM. It's an open source project, but there are a lot more, K-Gateway, some others. But the point is, you put everything behind the proxy, which also offers registries for tools, for MCPs, which also offers access control, rate limiting, control of what models are being accessed. And your architecture is greatly simplified. There are now things you don't need to protect from within your SDK or from within the, let's say, the different parts your agent is connecting to or querying, because everything is behind the proxy. And this is greatly simplifying our use case. Any other questions? All good? Then thank you very much.